Today we'll discuss Indian Statistical Institute, that is ISI's B-Math and B-Stat 2018 paper. Link to that paper, I'll provide it in the description below. Now again, questions in this paper, they're absolute delight. So let us get on with the first question. And the first question is, let x be a number that lies between 0 and 1 by 6. When a certain biased die is rolled, a particular face f occurs with probability 1 by 6 minus x, and its opposite face occurs with the probability 1 by 6 plus x. So we have this die. Where these two opposite faces, one of the probability is 1 by 6 minus x, and for the other it is 1 by 6 plus x. And for the remaining four faces, the probability is simply 1 by 6. Now, it also says, recall that opposite faces sum to 7 in any dice. So that means these two faces, it can be either 1 or 6 or 2 or 5 or 3 or 4 or their ordered pairs. That is 6, 1, 5, 2 or 4, 3. Now it says if the probability of getting the sum 7 is 13 by 96, we need to find the value of x. Now we need to find probability of getting the sum 7. So probability of getting the sum 7 is when we get either 1 6 or 6 1 or 2 5 or 5 2 or 3 4 or 4 3. Now out of these 6 pairs, there is exactly one pair with these probabilities 1 by 6 minus x and 1 by 6 plus x, and for the remaining 4 pairs it will simply be 1 by 6 and 1 by 6. So I can simply write it as 2 times 1 by 6 minus x into 1 by 6 plus x, and then plus 4 times it will be 1 by 6 into 1 by 6, and they have given that this probability is equal to 13 by 96. So I can write it as, so this is 2 and this is 1 by 6 square minus x square, and then plus 4 by 36 equals 13 by 96. So here will be 2 by 36 plus 4 by 36. 6 by 36 is simply 1 by 6 minus 2x square, and this is 13 by 96. So I can write 2x square as 1 by 6 minus 13 by 96. So it will be 96, and then this is 16 minus 13. So I'll write it as 2x square equals 3 upon 96, which is x square equals 1 by 64. So this value of x should be 1 by 8. That's your option number A. Now question number 2, it says an office has 8 officers including 2 who are twins. 2 teams, red and blue, of 4 officers each are to be formed randomly. What is the probability that twin would be together in red teams? So first we'll find total number of cases. So total number of cases will be when we distribute these 8 people in the teams of 4 and 4, and these teams, they are named. So one of them, it is red team, and the other team is simply blue team. So the total number of ways of distributing them is simply factorial 8 divided by factorial 4 factorial 4. Now we need to find this probability that these 2 twins, they'll be together in a red team. So we already have this red and blue team. Now these 2 twins, they are already included in this red team. So now we need to distribute remaining 6 people so that we get 2 people in red team and 4 in blue team. So it can be done in factorial 6 divided by factorial 2 factorial 4 ways. So what is the probability that these 2 twins are in red team? So this probability is equal to, so this is your favorable case, which is factorial 6 upon factorial 2 factorial 4 divided by factorial 8 factorial 4 factorial 4. So it will simply be factorial 6 into factorial 4 factorial 2 into factorial 8. So this is 12 and this is 8 into 7. So it will be simply 3 by 14, and that's your option number D. Now question number 3, it says, suppose Roger has 4 identical green tennis balls and 5 identical red tennis balls. In how many ways can Roger arrange these 9 balls in a line so that no 2 green balls are next to each other and no 3 red balls are together? So first we'll find in how many ways we can arrange these 4 green and 5 red balls so that no 2 green balls are together. So for that, what I'll do is I'll first arrange these 5 identical red balls. So it can be done in factorial 5 upon factorial 5, which is only one way. So I have arranged these red balls 1, 2, 3, 4 and 5. So when I have placed these 5 red balls, I have these 6 gaps. So if I'll place these green balls in either of these 6 gaps, then no 2 green ball will be together. So this is called as gap method. So out of these 6, I'll choose 4 gaps for these green balls. So it is 6C4 and then factorial 4 upon factorial 4. So it will be simply 6C4, which is 15 ways. Now from these 15 ways, we need to eliminate or we need to exclude all those cases when 3 or more red balls are together. So we look at the arrangement again. So this is 1, 2, 3, 4 and 5. Now we need to place green balls. So if I'll place these green balls such that 1, 2, 3 and 4. Now in this case, we'll have 3 red balls together, or I can place them as 1, 2, 3, 4 and another one is so here we'll have 3 red again, and here also we'll have 3 red again together. So there are 3 possible configurations where these 3 red balls are together among these 15 cases. So from these 15 cases, we'll need to subtract 3 cases where these 3 red balls are together. So total number of cases when no 2 green balls are together and no 3 red balls are together is simply 12, and that's your option number D. Now question number 4, it says we need to find number of permutations of 1, 2, 3, 4 such that mod of sigma I minus I should be less than 2 for every I that lies between 1 and 4, both inclusive. So here we have a set having 4 elements, 1, 2, 3, 4, and then we need to find its permutations so that this given condition is satisfied. So it is again 1, 2, 3 and 4. First we look at when the value of I is 1. So it will be simply sigma 1 minus 1 is less than 2. So here I'll get minus 2, sigma 1 minus 1 is less than 2. So minus 1, sigma 1 is less than 3. So that means, so for this one, there are 2 choices of permutations and it will be either 1 or 2. Now I'll write it for I equals 2. For I equals 2, it will be sigma 2 minus 2 is less than 2. So it will simply be minus 2, sigma 2 minus 2 is less than 2. So 0 and then sigma 2 and then 4. So for this 2, we have 3 possible permutations and they are 1, 2 and 3. Now if I'll put I as 3, I'll get sigma 3 minus 3 is less than 2. So I'll write minus 2 is less than sigma 3 minus 3 is less than 2. So it'll be 1 and then sigma 3 and then 5. So for 3, we have again 3 configurations, either 2, 3 and 4. So for 3 will be either 2, 3 and 4. And finally for I equals 4, I can write sigma 4 minus 4 is less than 2. So minus 2 is less than sigma 4 minus 4 is less than 2. So 2 is less than sigma 4 is less than 6. So here there are 2 values which are possible for sigma 4 and they are 3 and 4. So for this 4, we have 2 choices. So it will be either 3 or 4. Now, how many permutations are possible? So for this one, we have 2 choices, Either will be 1 or 2. For this 2, we have 3 choices, 1, 2 and 3. Now for 3, we have again 3 choices, 2, 3 and 4. And for 4, we have 2 choices, that is 3 or 4. So we'll consider first case when 1 is mapped to 1 and suppose 4 is mapped to 4. Now if 1 is mapped to 1 and 4 is mapped to 4, then the choices for 2 and 3 are 2, 3 and 3, 2. So in that case, we'll have 2 choices for 2 and 3. So this is 2, 3 and here also this is 2, 3. So here number of permutations will be simply 2. Now we'll consider second case when 1 is mapped to 1, 4 is mapped to 3. In that case, we now have this is 2 and 3 and here we have 2 and 4. Now for this 2, there is only one option, which is 2, and this 3 again will have only one option. So there is only one case when 1 is mapped to 1 and 4 is mapped to 3. Now we'll consider this third case, and this third case when 1 is mapped to 2 and 4 is mapped to 4. Now we are left with 2 and 3, and then we are left with 1 and 3. Now 3 cannot take 1, so 3 has to be mapped with 3 and 2 has to be mapped with 1. So this is only one case, and then finally the last case, which is when 1 is mapped to 2 and 4 is mapped to 3. So again we are left with 2, 3 and here we have 1 and 4. So here 2 can only have 1 and 3 can only have 4. So there is this one more case. So the total number of cases here will be simply 5. So answer to this question is 5, which is option number D. Now question number 5, it says fx is a degree 4 polynomial with real coefficients. Let z be number of real roots or real zeros of f and e be number of local extremum, that is local minimum or maximum. Then which of the following is a possible pair? So if a function has 4 roots, then it simply means it will intersect x-axis at 4 points. So if the function intersects x-axis at 4 points, so in that case, the maximum number of extremum that this function can have is 3. So it cannot have 4 extremums. So that means option number A is not possible. Now, second option given is 3, 3. Now, when it says it has 3 real roots, so a polynomial equation of degree 4 can have 3 real roots only when we have 3 distinct roots. So that means all the 4 roots, they should be real, because it is not possible to have 3 real and 1 imaginary roots. So that means here in this case, there'll be one root which will be a double root, and other 2 roots, they'll be simply distinct roots. So in this case, the condition can be where this function, it touches x-axis at one place. So now in this case, we have 3 distinct roots, and then we can also have 3 extremums, that is 2 maximum or a minimum, or 2 minimum or a maximum. So for this given function or given polynomial, it is possible to have 3 roots and 3 extremums, and that's your option number B. Now question number 6, it says we have this palindrome. So palindrome is if it reads the same backwards and forwards. Now for example, 112211 is a palindrome. So it says how many 6-digit palindromes are divisible by 495. So we will factorize this 495, we'll get 5 into 11 into 9. Now this number will be divisible by 495 when it is divisible by 5, when it is divisible by 11, and when it is divisible by 9. So we have this 6-digit number. Now this number has to be divisible by 5. So that means this number, it should be either 0 or 5. Now it is a palindrome. So that means this digit will be repeated here also. So this cannot be 0. So this last digit, it has to be simply 5. So there is only one choice for this first and last position. Now we have, suppose these two numbers is AB and BA, which makes it a palindrome. Now we look at divisibility by 11. So for divisibility by 11, we look at sum of digits at the even places minus sum of digits at odd places. So what is the sum of digits at even places? So sum of digits at even places is a plus b plus 5. And what is the sum at odd places? So sum at odd will be 5 plus b plus a. So that means sum of even minus sum of odd is simply 0, which is divisible by 11. So this number will be divisible by 11 for any values of a and b. Now we need to find out this number should be divisible by 9. So a number is divisible by 9 if sum of digits are a multiple of 9. So that means 5 plus a plus b plus b plus a plus 5, and it should be some 9k. So I can write 2 times a plus b plus 10, and it should be some multiple of 9. Now we know that this a and b, they belong to this set which is 0, 1, 2 and up to 9. So what is the minimum value of a plus b? Minimum value of a plus b is 0 and maximum value of a plus b here is 18. Now we need to find all the possible combinations of this sum a plus b so that this 2 times a plus b into 10 is divisible by 9. So this number, it can be 18, and it'll be 18 when we have 2 into 4 plus 10. So one of the possibility is the value of a plus b, it should be 4. So what are the possibilities? Possibilities are 0, 4, 1, 3, 2, 2, 3, 1 and 4 zeros. So that means we have 5 possibilities here. Another one could be when we have this number as 36. It cannot be 27 because here this is 2 and this is 10. Both of them, they are even numbers. So it cannot sum to 27. So if it is 36, then it simply means value of a plus b, it should be 13. Now the other combination that we need to check is when the value of a plus b is 13. So what are the possible combinations? So possible combinations are 4, 9, 5, 8, 6, 7, 7, 6, 8, 5 and 9, 4. So these are the possible configurations where the sum a plus b into 2 plus 10 is a multiple of 9. So which is 5 and then 6, 11 cases. So the total number of 6-digit palindromes which are divisible by 495 is simply 11. That's your option number B. Now question number 7, it says we are given this condition which is a to the power 4 is equal to a, then which of the following is true for every such a? So if we'll take the determinant, we can write determinant of a to the power 4 equals determinant of a. So this is determinant of a to the power 4 equals determinant of a. So if I'll take it here on the left hand side, I'll write determinant of a to the power 4 minus determinant a is 0. So this is determinant a and then determinant of a cube minus 1 equals 0. So I'll get either determinant of a is 0 or determinant of a is 1. So option number A is determinant of a is unequal to minus 1. So we know that this determinant will be either 0 or 1. It cannot be minus 1. So that means option A is correct. Now a must be invertible. Suppose we have this condition when determinant of a is 0. In that case, a won't be invertible. So option number B is incorrect. A cannot be invertible. So it is possible to have determinant of a equals 1. In that case, it'll be invertible. So this option is again not true. And this fourth option, which is a square plus a minus I is equal to 0. So we are given that a4 minus a is equal to 0. So I can write a into a cube minus I equals to 0. So I'll write it as a, then a minus I, and then a square plus I equals to 0. So here in this case, it may not necessarily be true that this a square plus a plus I is a null matrix. So that means option number D is also not necessarily true. So answer to this question is simply option number A. Now in question number 8, it says there is a real valued function h such that h0 is 5, h100 is 20, and hi is 1 by 2 hi plus 1 plus hi minus 1. That means this hi, it is arithmetic mean of hi plus 1 and hi minus 1. So which makes this sequence an arithmetic progression. So this sequence is nothing but an arithmetic progression. So first term for this sequence is 5, and 101th term is simply 20. So that's your first term and that's your 101th term. So we can find its common difference. So A101 is A1 plus 100 into D. So here it is 20 minus 5 and this is 100D. So value of D is simply 3 by 20. Now we'll need to find value of H1. So H1 simply is 5 plus D, which is 5 plus 3 by 20. So it is 103 divided by 20, and which is 10.3 divided by 2. So this is 5.15, and that's your option number A. Question number 9, it says an upright path is a sequence of points x0, y0 and x1, y1, x2, y2 such that ai plus 1 minus ai is either 1, 0 or 0, 1. We need to find number of upright paths from 0, 0 to 100, 100 which pass through 1, 2. So we have this grid starting from 0, 0, and then we have these lines, horizontal and vertical lines, and we'll need to reach 100, 100 such that the path passes through 1, 2, and we need to get an upright path. So an upright path is either we go one step up or we go one step right, which is increment of 1, 0 or increment of 0, 1. So now we have this point which is 1, 2. So this is your point which is, so this is the point which is 1, 2. So first we'll find out if we'll start from 0, then in how many ways we can reach this point 1, 2. So in order to reach this point, we'll have to cross one horizontal path and two vertical paths. So what are the possible arrangements of one horizontal and two vertical paths? So total arrangements possible for one horizontal and two vertical is factorial 3 divided by factorial 2 factorial 1, and it will be simply 3. So from 0, 0 to 1, 2, so there are 3 paths possible with this upright path. Now from 1, 2, we'll need to go to 100, 100. So if we have to reach 100, 100 from 1, 2, then in that case, we'll need to cross 99 horizontal paths and we'll need to cross 98 vertical paths. Now in how many ways we can arrange these 99 horizontal and 98 vertical paths? So from 1, 2 to 100, 100, the total number of arrangements here will be 99 plus 98. So it will be factorial 197 divided by factorial 99 into factorial 98. So in how many ways we can start from 0, 0 and go up to 100 passing through 1, 2. So total number of such arrangements will be this number 3 multiplied by 197 factorial upon 99 factorial and 98 factorial, and which is simply 3 into 197 C 99, and that's your option number A. Now question number 10, it's a limits question. It says the smallest positive integer k such that this limit is unequal to 0. So we are given this limit which is limit x tends to 0, and then fx here is 1 by 2 x sin x minus 1 minus cos x upon x to the power k. So we know that this is 0 upon 0 form. Now the best way to solve this question is using expansion formulas. So I'll use expansion formulas. So I'll write limit x tends to 0, and this is 1 by 2x. Then expansion of sin x will be x minus x cube upon factorial 3, and then minus. So this is 1 minus, and here will be 1 minus x square upon factorial 2 plus x to the power 4 upon factorial 4 upon x to the power k. Now in the numerator, this 1 and 1 will get cancelled, and then x square by 2 and x square by 2 will also get cancelled. So what is the minimum power of x in the numerator? So minimum power of x in the numerator simply will be x to the power 4, and this limit will have finite non-zero answer only when the minimum power of x in the numerator is same as minimum power of x in the denominator. So it simply means for this limit to have non-zero finite answer, the value of k should be 4, and that's your option number B. Now in question number 11 it says there are 9 students in a class and they gave a test for 50 marks. Let S1 is less than equal to S2 is less than equal to S9 denotes their ordered scores. Now it is given that S1 is 20 and sum of all marks is 250. So let small m be the smallest value that S5 can take and capital M be the largest value that S5 can take. We'll need to find the value of small m and capital M. So what we are given is this sum S1 plus S2 plus S3 plus S4 plus S5 plus S6 plus S7 plus S8 plus S9, and this sum, it should be 250. Now we are given that this S1, its value is 20. So S1 is less than equal to S2, which is less than equal to S3, which is less than equal to S4, and it is less than equal to S5. So the minimum value that this S5 can have is at least 20. So this minimum value of S5, it should be simply 20. Now we need to check if it is possible for S5 to have this value 20. Now suppose the value of S5 is 20 in that case. So S1 is 20. So this is 20 plus 20 plus 20 plus 20 and plus 20. S6 plus S7 plus S8 plus S9. So it will simply be 150, and it is possible to have sum of 4 scores as 150 as the highest marks for the test is 50. So that means S5 can take minimum value of 20. Now what is the maximum possible value for S5? So now we know that this S1 starts with 20, and then if these numbers, they take the minimum value possible, so which is 20 plus 20 plus 20, and then all the remaining numbers, they take the value same as that of S5, which is M, so which is 5M, then this S5 will take its maximum value. So now we need to check whether such condition is possible. So I'll write 5M equals 250 minus 80. So 5M is 170. So capital M is 34. So the ordered pair of small m and capital M should be 20 and 34, and that's your option number B. Now question number 12 says there are 10 red balls and 10 white balls which are to be arranged in a straight line such that 10 each are on either side of central mark. So we have this central mark, and then we have 10 balls to the left and 10 balls to the right. The number of such symmetrical arrangements about central mark. Now this arrangement, it has to be symmetrical about central mark. So that means on the left, I must have 5 red and 5 white. And on the right also, I'll have 5 red and 5 white. Now since the arrangement is symmetrical, so what we'll do is we'll arrange these 10 balls on the left. And if we'll arrange these 10 balls, then these 10 balls on the right, they'll be automatically arranged according to the configuration on the left, because it says these arrangements are symmetrical. So this problem reduces to arrangement of this 5 red and 5 white balls. Now it can be done in factorial 10 upon factorial 5 divided by factorial 5 ways. So answer to this question is factorial 10 divided by factorial 5, and that's your option number A. Now question number 13, it's a very simple question. It says mod of z minus iota upon z plus iota is less than 1. Now we know that mod of z1 upon z2 is, so mod of z1 upon mod of z2, and this is less than 1. So I'll write mod of z minus iota is less than mod of z plus iota. Now here I'll write this is x plus iota y minus 1, and this is x plus iota y plus 1. So we'll take modulus, we'll get under root of x square plus y minus 1 whole square, and this is under root of x square plus y plus 1 whole square. So here I'll get x square plus y square plus 1 minus 2y is less than x square plus y square plus 1 plus 2y. So we'll simplify, we'll get y is greater than 0, and that's your option number C. Now question number 14, it says there is this set S which is x minus y with real numbers such that x square plus y square equals to 1. Then we need to find maximum number in this given set S. Now we know that the condition given is x square plus y square equals to 1. So it simply means I can take this x as some cos theta and this y as some sin theta. Then it will satisfy this condition, which is cos square theta plus sin square theta equals 1. Now the set S given is x minus y, which in this case will be simply cos theta minus sin theta. So now here it is a cos theta plus b sin theta. So I'll multiply and divide it with under root of a square plus b square. So which is root 2. So I'll multiply and divide it with 1 by root 2. So I'll write this set S as this is root 2 and this is cos theta plus pi by 4. Now what is the maximum value of cos? Maximum value of cos is 1. So the maximum number in this set S will be simply root 2. And that's your option number B. Now question number 15, it says in a factory, 20 workers start working on a project of packing consignments. They need exactly 5 hours to pack one consignment. Every hour, 4 new workers join the existing workforce. It is mandatory to relieve a worker after 10 hours. Then we need to find number of consignments that would be packed in the initial 113 hours. So the queue starts at t equals to 0. And then we have t equals 1, 2, 3, 4, 5, and then 10, 11, 12, and it'll continue up to 113 hours. Now at t equals to 0, we have started with 20 workers. So we'll start with 20. And then at 1, we'll need to add 4 more workers. So now it'll be 24. Here will be 28, 32. So we'll keep adding them till this 9. And here it will be 36 plus 20. So it will be simply 56. Now at 10th hour, all these 20 workers, they'll retire because it is mandatory to relieve a worker after 10 hours. So all these 20, they'll be relieved, and then we'll add 4 more. So in that case, we'll have this 40. And after that, after every hour, we'll add 4 and we'll subtract 4. So from 10 onwards, it'll be simply 40 workers working. So what is the total number of man-hour work possible? So total man-hour work will be, so this is 20 plus 24 plus 28 up to 56, and then it will be simply 40 plus 40 plus 40, and then it goes all the way up to 40. So this is n by 2. So it is 10 by 2, and then a plus L. So it will be 20 plus 56, and then plus it will be 40 into 113 minus 10. So there will be simply 103. So total number of man-hour work possible is 4500. So we need to find total number of consignments that would be packed. So total number of consignment that can be packed is 4500 divided by, now it takes 5 hours and 20 workers to pack one consignment. So that means it takes 20 into 5 man hours. So it'll be simply 45. So in this duration of 113 hours, number of consignments that would be packed is simply 45. That's your option number C. Now question number 16, it says, let ABCD be a rectangle with shorter side a greater than 0 units and perimeter of 2s units. So we have this rectangle whose shorter side is a and its Perimeter is 2s. So this other side will be simply s minus a. So this is a, b, c and d. Now it says let PQRS be any rectangle. So let PQRS be any rectangle such that vertices ABCD lie on PQ, QR, RS and SP. So we have another rectangle PQRS such that A lies on PQ, B lies on QR, C lies on RS and D lies on SP. So we need to find the maximum area of such a rectangle PQRS. Now for this rectangle PQRS and ABCD, suppose this angle is theta. Now this AQ will be S minus A cos theta. Now here this angle, now it is 90. So it is 90 plus theta and here will be 90 minus theta. So here this angle will be simply theta. So here it should be A sin theta. So length of the side PQ will be A sin theta plus S minus A cos theta. Now for this one, this length is S minus A sin theta. Now this is 90 minus theta. This is 90. So this angle will be theta. This is A and here will be A cos theta. So here QR will be S minus A sin theta plus A cos theta. So area of this PQRS simply will be PQ into QR. So here will be A sin theta plus S minus A cos theta into S minus A sin theta plus A cos theta. So we'll multiply, we'll get this area as A into S minus A sin square theta plus A square sin theta cos theta plus S minus A square into sin theta cos theta and then plus A into S minus A cos square theta. Now sin square theta plus cos square theta will be 1. So I can write this area as A into S minus A and then plus here we'll have A square plus S minus A whole square into sin theta into cos theta. So I'll multiply it by 2 and I'll divide it by 2. So now this is sin 2 theta. Now maximum value of sin 2 theta is simply 1. So the maximum area of this rectangle will be A into S minus A plus 1 by 2 into A square plus S minus A whole square. So this maximum area will be, so I'll take this 1 by 2 common. So I'll write twice AS minus 2A square and then plus A square plus S square plus A square minus twice AS. Now 2AS will cancel, 2A square and 2A square will also cancel. So maximum area of this rectangle will be simply S square by 2 and that's your option number C. Now question number 17, it says find the number of pair of integers x and y satisfying the equation xy x plus y plus 1 and this is 5 to the power 2018 and then plus 1. Now we'll consider left hand side and right hand side separately. So left hand side is xy into x plus y plus 1 and right hand side is 5 to the power 2018 and then plus 1. So we know that any power of 5 will end with 5 and then plus 1. So this right hand side will always be an even number. So this RHS, it is even, and we can also write this 5 as 4 plus 1 to the power 2018 plus 1. So here I can write it as this is some multiple of 4 plus 1 and then plus 1. So it is of the form 4k plus 2. So this right hand side will be even, but it is not divisible by 4. Now we'll come to left hand side. So now we know that right hand side is even. So this left hand side, it must also be an even number. So left hand side will be even when at least one of x or y is even. So suppose x is even, y is odd. Now if x is even and y is odd, so this x, it is even, y is odd, and then into, now this is even and then odd plus 1 is also even. So this number will also be an even number. So it is even into even. So it means this left hand side is divisible by 4. So 4 divides left hand side. Now when I have, suppose x is even and y is even. Suppose both the numbers they are even. So if both the numbers they are even, then x into y again will be divisible by 4. So for any possibility of x and y, this left hand side will always be divisible by 4 and this right hand side is not divisible by 4. So that means left hand side can never be equal to right hand side. So that means the number of pairs of integers satisfying the equation will be simply 0. So there is no solution to this equation. Now question number 18, it says let Pn be number of digits when 8 to the power n is written in base 6, and let Qn be number of digits when 6 to the power n is written in base 4. We need to find this limit, which is limit n tends to infinite Pn Qn upon n square. Now there is a direct formula for that. So if we write 8 to the power n to the base of 6, then number of digits Pn, it is given by greatest integer function of log 8 to the power n to the base 6 and then plus 1. So this is the formula to find out number of digits in other base. So in the same way, we can find number of digits Qn when the base is 4. So Qn will be log base is 4 and number here is 6 to the power n and plus 1. So basically Pn is n log 8 base 6 plus 1 and Qn is greatest integer n log 6 base 4 plus 1. Now we need to find this limit, which is limit n tends to infinite Pn into Qn upon n square. Now in greatest integer function, we know this property that greatest integer function of x is always less than or equal to x and it is greater than x minus 1. So I can write Pn is less than or equal to n log 8 base 6 plus 1 and it is greater than n log 8 base 6. In the same way, we can write Qn. So Qn will be less than n log 6 base 4 plus 1 and here will be n log 6 base 4. Now if we multiply them, then we can write it as n square log 8 base 6 into log 6 base 4 is less than Pn into Qn and it is less than n log 8 base 6 plus 1 into n log 6 base 4 plus 1. So now I'll need to find this limit. So I'll need to divide it with n square. So I'll also divide it with n square. So if I'll divide it with n square and I'll take this limit also. I'll take this limit n tends to infinite. Now since it is an infinite limit, so highest power of n in the numerator and denominator is 2. So answer to this left hand limit will be simply log 8 into log 6 and here it is limit n tends to infinite Pn Qn by n square, and here also the highest power is n square. So here also this limit will be log 8 base 6 into log 6 base 4. Now sandwich theorem says if fx lies between gx and hx, and if limiting value of gx is L and limiting value of hx is L, then the limiting value of this limit is also L. So which simply means the value of this limit is equal to log 8 base 6 into log 6 base 4. So I can write it as log 2 base 8 upon log 6 base 2, and here will be log 6 base 2 upon log 4 base 2. So it will cancel. So 8 is 2 cube and 4 is 2 square. So the value of this limit is simply 3 by 2, and that's your option number C. Now question number 19 is, for a real number alpha, let S alpha denote the set of those real numbers beta that satisfy alpha sine beta equals beta sine alpha. Then which of the following statements is true? So I can rearrange this equation as sine beta upon beta equals sine alpha upon alpha. In order to solve this question, I'll consider this function, which is fx equals sine x upon x. So now I'll draw the graph of sine x upon x. So we know that we can draw this y equals 1 upon x. And then we can take its reflection. So limit x tends to 0, sine x upon x, it is 1. So this value will start with 1. And there will be the graph of sine x upon x. So it's an approximate graph of sine x upon x. What I'll do is I'll import a graph. Now if I choose any point on x-axis, which is alpha, then the value of y here will be sine alpha upon alpha. And if I'll draw a horizontal line, so this line, it intersects this graph again at this point. Maybe this is beta. So here it will be sine beta upon beta, such that sine beta upon beta is equal to sine alpha upon alpha. Now we look at option number A. Now option number A, it says S alpha is an infinite set for any alpha, which is not true. If I choose alpha between 0 and this point of intersection, which is pi by 2, in this case, for one value of alpha, I'll get only one value of beta. So it is not necessarily an infinite set. So option A is incorrect. So I'll come to option number C. Option number C, it says there are infinitely many numbers alpha for which S alpha is set of all real numbers. So it doesn't matter wherever I'll put this line, I'll get these point of intersections, but then these point of intersections, they'll never make the set of all real numbers. So that means option number C is also incorrect. Now option number D, S alpha is always finite. So if I'll choose alpha as n pi, in that case I'll get sine beta upon beta equals sine n pi, which is 0. So I'll get sine beta equals 0. So in that case I'll get beta equals m pi. So there'll be infinite solutions in this case. So if I'll choose alpha as n pi, in that case, if I draw this horizontal line, then it will have infinite points of intersection. So that means option D is also incorrect. Now what about option B? It says S alpha is a finite set if and only if alpha is not an integer multiple of pi. If it is an integer multiple of pi, then it will intersect this graph at infinite points, and for all other values of alpha, the number of points of intersection will always be finite. So that means option number B is a correct option. Now in question number 20, we are given this matrix A, and which is 1, 1, 0 iota, and it also says this a to the power 2018 is ABCD. We need to find the value of A plus D. Now we'll find A square. So A square will be 1, 1, 0 iota, 1, 1, 0 iota. So if I'll multiply them, I'll get 1, 1 plus iota, 0, and then minus 1. Now I'll find A cube. So A cube will be 1, 1 plus iota, 0 minus 1, and here will be 1, 1, 0 and iota. So I'll write, so this is 1 and this is 1 plus iota minus 1, so which is simply iota, and this is 0, and here will be simply minus iota. So it is 1 iota, 0 and minus iota. Now I'll find a to the power 4. So a to the power 4 will be 1 iota, 0 minus iota, and here it is 1, 1, 0 and iota. So we'll multiply it, we'll get this as 1. Here we'll get 1 and plus iota square, which is minus 1, 0. Here will be 0, and then here will be 1. So it is an identity matrix. So that means a to the power 4 is simply equals to identity matrix. Now this a to the power 2018, we can write it as a to the power 2016 into a square, and this is a to the power 4, and this is 504 into a square. Now a to the power 4 is identity matrix, and I to the power 504 is I, and I to a square is simply a square. So that means a to the power 2018 is equal to a square, and a square is 1, 1 plus iota, 0 and minus 1. Now they have given it equal to a, b, c, d. We need to find the value of a plus d. Value of a plus d simply will be 1 minus 1, and it is 0. So answer to this question is 0, which is option number B. We are given two statements. P1 is if limit fx exists and limit fx into gx exists, then it implies limit gx must exist. It may not necessarily be true. So now suppose I have this function fx whose limiting value is 0, and suppose I have this gx whose left hand limit is L1 and right hand limit is L2, and L1 is not equal to L2. So if I'll multiply both of them, then every time when I'll solve fx into gx, I get left hand limit as 0 and right hand limit as also 0. In this case, this limit fx into gx exists even when this limit gx doesn't exist. So this P1 is wrong. Now second condition, it says if f and g are differentiable with f is less than g, then it says f dash is less than g dash for all x. So this again may not be true. So we need two functions such that f should lie below g. So I'll consider two functions. Suppose this is g and it is e to the power minus x, and suppose this is f, which is minus e to the power minus x. So clearly f is less than g, but if I'll differentiate, I find g dash x, here will be minus e to the power minus x, and f dash is e to the power minus x. Now here g dash is actually less than f dash. So that means again statement 2, it may not necessarily be true. So both these statements, they are not necessarily true. So that means both P1 and P2 are false. Now question number 22, it says number of solutions of this equation, which is sine 7x plus sine 3x equals to 0 in the interval 0 to 2 pi. So I'll use sine c plus sine d. So it will be 2 sine c plus d by 2. So it will be sine 5x and then cos c minus d by 2. So it will be cos 2x equals 0. So I'll get this condition as sine 5x should be 0 or cos 2x is 0. So sin x is 0 when x is n pi. So here it is x equals n pi by 5, where n belongs to an integer, and here cos 2x equals to 0. So I'll get 2x equals 2m plus 1 into pi by 2. So that is x should be 2m plus 1 into pi by 4 for m belongs to z. Now we need to find for how many values of m and n this solution or this value x, it lies in this interval between 0 and 2 pi. So I can start with n equals to 0, 1, and then what is the maximum value that n can take? The maximum value that n can take is simply 10, because in that case it will be simply 2 pi. Now what about m? So minimum value of m is simply 0, and then it goes all the way up to m equals 3. If I'll take m as 4, I'll get this as 9 pi by 4, which is greater than 2 pi. So here we'll have 11 values of n, and here we have 4 values for m. So number of solutions will be 11 plus 4, which is 15, and that's your option number C. Now question number 23, it's a Bayes theorem question. It says a bag contains some candies. 2/5 of them are made of white chocolate and 3/5 are made from dark chocolate. So we have two kind of chocolates. So some of them they are white and some of them they are dark. So the probability that we get a white chocolate is 2 by 5, and the probability of getting a dark chocolate is simply 3 by 5. Now out of white chocolates, 1/3 are wrapped in red papers. So these chocolates, they're wrapped in either red papers or blue paper. So the probability that white chocolate, they're wrapped in red paper is 1 by 3, and it is wrapped in blue paper will be 2 by 3. In the same way for dark chocolate, the probability that it is wrapped in red paper is 2 by 3, and probability that it is wrapped in blue paper is 1 by 3. Now it says if a randomly selected candy from the bag is found to be wrapped in red paper, then what is the probability that it is made up of dark chocolate? So it is a Bayes theorem question. So we need to find the probability that it is made up of dark chocolate when it is wrapped in red. So that means we need to find this probability that it is dark when it is wrapped in red. So we'll put this case when it is a dark chocolate and with red paper in the numerator. So it will be simply 3 by 5 into 2 by 3, and in the denominator we'll put the probability of getting a red paper. So we'll get a red paper when it is white and red or when it is dark and red. So here will be 2 by 5 into 1 by 3 plus 3 by 5 into 2 by 3. So this probability of getting a dark when it's a red paper is, so this is 6 by 15, and here it is 8 by 15. So it is simply 3 by 4, and that's your option number B. Now question number 24, it says a party is attended by 20 people. In any subset of 4 people, there is at least one person who knows all the other 3. Now suppose there are 3 people in the party who do not know each other, then how many people in the party know everyone? So suppose we know there are 3 people A, B and C who do not know each other, and then there are other 17 people. Now out of these other 17 people, let us assume that there are 2 people D and E who do not know each other. So we can have this condition when we have this, when we have A, B, D and E. So we'll choose a group of 4 in which we have A, B, D and E. Now clearly A doesn't know B. Now this D, it doesn't know E. Now B doesn't know A and E doesn't know D. So it contradicts the condition that in any subset of 4 people, there is at least one person who knows the other 3. So that means we cannot have any 2 people who do not know each other. So which simply means all these 17 people, they must know everyone. So answer to this question is, how many people in the party know everyone? So all the remaining 17 people, they must know everyone. Now question number 25, it says we need to find sum of all natural numbers A such that A square minus 16A plus 67 is a perfect square. I'll say suppose this is equal to sum n square. Now I'll make it a perfect square. So I'll write A square plus 16A plus 64 plus 3, and this is n square. So I'll write this is A minus 8 whole square plus 3, and this is equal to n square. So I'll take A minus 8 on the right hand side. So I'll write n square minus A minus 8 whole square is equal to 3. So I'll write n plus A minus 8 into n minus A plus 8, and this value, it should be equal to 3. Now this left hand side, it's a product of 2 numbers. That means this right hand side, it must also be expressed as product of two numbers. So either these two numbers can be 3 into 1. So in that case, I can write this as n plus a minus 8 equals 3, and then n minus a plus 8 equals 1. So in this case, if I'll subtract it, I'll get 2 times a minus 8 is equal to 2. So value of a, it should be 9. Now the other case, when n plus a minus 8 is 1 and n minus a plus 8 is 3. So now if I'll subtract it again, I'll get 2 times a minus 8 is equal to minus 2. A minus 8 is equal to minus 1. So value of a is 7. So we are getting two values of a. So either a can be 9 or a can be simply 7. So sum of all natural numbers a. So sum of all natural numbers a will be 7 plus 9, which is 16. And that's your option number C. Now in question number 26, it says the sides of regular hexagon A, B, C, D, E, F are extended by doubling them to form a bigger regular hexagon A dash, B dash, C dash, D dash, E dash and F dash as shown in the figure. So we'll need to find ratio of the areas of bigger to the smaller hexagon. Now suppose length of this side is A. So this is A for each of these 6 sides. So what is the area of small hexagon? So area of this smaller hexagon will be 6 times root 3 by 4 into a square. So there will be simply 3 root 3 by 2 into a square. Now for this bigger hexagon, we know that all the sides, they are extended by this number a. So this is a, this is a. So these two numbers. So this side is a and this side is simply 2a, and this angle, it is 60. Now what is the area of this triangle? So area of this blue triangle will be 1 by 2. Now sides a into 2a and then sine of angle between them, which is sine 60. So it will simply be root 3 by 2 into a square. So what is the area of this bigger hexagon? So area of this larger hexagon will be 6 times area of this blue triangle. So this is 6 into root 3 by 2 into a square, and then plus area of this small hexagon, which is 3 root 3 by 2 into a square. So here I'll get 9 root 3 by 2 into a square. Now we'll need to find ratio of areas of bigger to smaller hexagons. So we'll need to find ratio of this areas. So this is 9 root 3 a square by 2, and here it is 3 root 3 a square by 2. So if I'll cancel it, I'll get this value as 3. So it is 3:1 ratio, or which is option number B. Now it says between 12 noon and 1 p.m. there are two instants when the hour hand and the minute hand of a clock are at right angles. We need to find difference in minutes between these two instants. So suppose we have this clock. Now at some time, this hour end and this minute end, they'll form this 90-degree angle, and then after a while again these two, they'll make 90-degree angles. So we'll need to find the difference in minutes between the two instants. First we'll find angular velocity for hour end and minute end. So angular velocity for hour end will be, so it covers 2 pi angle in 12 hours. So which is 12 into 60 minutes. So it'll be 2 pi upon 720 minutes. So angular velocity of this hour end is 2 pi upon 720 radian per minutes. Now what is the angular velocity of this minute hand? So this minute hand completes this angle 2 pi in 60 minutes. So it is 2 pi by 60 radian per minute. Now suppose at first when they make an angle 90 degrees, this time is T1, and next when they make angle 90 degrees is this time T2. So we write the equation for this time T1, then we can write omega m minus omega h into T1, and this is equal to pi by 2. So what is omega m minus omega h? So it is 2 pi by 60 minus 2 pi by 720 into T1, and this value is pi by 2. Now at T2 we can write this equation as 2 pi by 60 minus 2 pi by 720 into T2. Now at this time the angle between them is actually 3 pi by 2. So this angle will be simply 3 pi by 2. Now we'll need to find difference in minutes between the two instants. So what I'll do is I'll subtract this first equation from this second equation. So if I'll subtract first from second, I'll get 2 pi by 60 minus 2 pi by 720, and this is T2 minus T1, and this is 3 pi by 2 minus pi by 2, so it is simply pi. So I'll take 2 pi common. So actually I'll take 2 pi by 60 common. So I'll take 2 pi by 60 common, and here I'll get 1 minus 12 into T2 minus T1 into pi. So I'll cancel this pi, and here I'll write this is 30. So T2 minus T1 will be 30 into 12 upon 11, so which is 360 by 11. So it is 32 and then 8 by 11. That's your option number A. Now question number 28, it says, for what values of theta between 0 and pi by 2 this quadratic polynomial has repeated roots? Now condition for repeated roots is value of d should be 0. So here I'll get 16 cos square theta minus 4 cot theta. It should be 0. So I'll get 4 cos square theta, and here will be cos theta upon sin theta. So I'll get either cos theta equals 0 or 4 sin theta into cos theta equals 1. Now cos theta equals 0, I'll get theta equals pi by 2, which is not included. So here I can write 2 sin 2 theta equals 1, or the value of sin 2 theta is equal to 1 by 2. So value of sin theta, it is 1 by 2 at either pi by 6 or sin 5 pi by 6. So that means this 2 theta, it is either pi by 6 or 2 theta is 5 pi by 6. So that is, this value of theta should be either pi by 12 or 5 pi by 12, which is option number D. Now question number 29 says, let alpha, beta, gamma be complex numbers such that they are vertices of an equilateral triangle. So we know this standard result, that is, if Z1, Z2 and Z3 are vertices of an equilateral triangle, then the condition is Z1 square plus Z2 square plus Z3 square equals Z1 Z2 plus Z2 Z3 plus Z3 Z1. Now in this case, we have taken alpha, beta, gamma in place of Z1, Z2 and Z3. So I can write alpha square plus beta square plus gamma square minus alpha beta minus beta gamma minus gamma alpha. It should be 0. So I'll multiply it by 2. 2 alpha square plus 2 beta square plus 2 gamma square minus 2 alpha beta minus 2 beta gamma minus 2 gamma alpha equals 0. So I'll take alpha square beta square minus alpha beta. So I'll write alpha minus beta whole square plus beta minus gamma whole square plus gamma minus alpha whole square is equal to 0, and that's your option number D. Now this is very standard result. You'll get it in any standard textbook. Otherwise you can get this result using rotation. So suppose we have 3 vertices. This is Z1, Z2 and Z3. It's an equilateral triangle. I can write Z2 minus Z1 upon Z3 minus Z1, and it should be equals to Z1 minus Z3 upon Z2 minus Z3. So we'll solve this rotation, then you'll get this standard result. Now question number 38 says, assume that n copies of unit cubes are glued together side by side to form a rectangular solid block. If the number of unit cubes that are completely invisible is 30, then we need to find minimum possible value of n. So let us take this rectangular block. Containing 1 cross 1 pieces. Now suppose here this length is L, suppose B, and then this is suppose H. So we know that LBH is equal to simply N. Now what is the number of cubes which are invisible? So for these invisible cubes, we'll have these dimensions as L minus 2, B minus 2 and H minus 2. So number of invisible cubes will be simply L minus 2, B minus 2 into H minus 2, and this number it is equal to 30. So that means this relation L minus 2 into B minus 2 into H minus 2, it is equal to this product, which is 30. Now these L minus 2, B minus 2 and H minus 2, they must be positive integers. So that means I have to express this 30 as a product of integers. So I can write this 30 as 2 into 3 into 5, or I can write it as 1 into 6 into 5, 1 into 3 into 10, or 1 into 2 into 15, or 1 into 1 into 30. So we can write all possible combinations for L minus 2, B minus 2 and H minus 2. So the possible combinations for L minus 2, B minus 2 and H minus 2 are 2, 3, 5, 1, 6, 5, 1, 3, 10, 1, 2, 15, and then 1, 1 and 30. So from here we'll get L, B and H as, so this is 4, 5 and 7. Now here will be 3, 3, 3 and 3. Here will be 6 plus 2, 8, 8, 5, 4, 3. Now 7, 12, 17 and 32. Now we need to find the configuration where this L into B into H, that is N, it should be minimum. So we'll multiply them. I'll get this as 140. Here will be 168. It is 180. This is 204. And this is 288. So the minimum possible value of N is simply 140. So which is your option number C. If you like the video, consider subscribing and sharing it with someone you know who might benefit from it. Also, the best way to navigate any topic is through a playlist. Simply go to the channel page, click playlist and select the topic you wish to study.